The damp concrete walls of hastily erected prisoner processing centers echoed with murmurs in German as the once mighty Wehrmacht crumbled in the spring of 1945. Among thousands of captured soldiers, a distinct subset watched American MPs with particular apprehension. The engineers, scientists, and technical specialists who had designed and maintained the Third Reich's war machine. As they lined up for processing, these men carried more than standard-issue gear. They carried valuable knowledge that made them both prized and vulnerable. Name, rank, specialty, the American processing officer repeated mechanically in accented German, his rubber stamp hitting each form with metronomic precision. For most prisoners, the answer was simple: infantryman, radioman, cook. But when Hans Müller, a 31-year-old electrical engineer who had worked on radar installations along the Atlantic Wall, stated his occupation, the officer paused, made a notation, and called over a lieutenant. This scene played out countless times across the European theater as American forces captured over 425 Azurzere German prisoners in the war's final months. The processing system, while overwhelmed by sheer numbers, contained specific protocols for identifying prisoners with technical backgrounds. Special intelligence officers, many of them German-speaking immigrants who had fled Nazi persecution years earlier, conducted secondary interviews with anyone whose skills might prove valuable. For men like Müller, these interviews triggered profound anxiety. Word had spread through German military ranks about the fate of technical specialists captured by the Soviets. Engineers sent east often disappeared into specialized labor camps, forced to rebuild Soviet industry without compensation or hope of release. Many German technical personnel genuinely feared that admission of their skills would condemn them to years of intellectual slavery. "We had heard that in Russia, if you were an engineer, you would never come home," recalled Karl Baumann, a mechanical engineer captured near Frankfurt, in a 1978 interview preserved at the National W. Museum. Some men threw away their technical papers, tried to hide their education. Better to be thought a simple soldier than an engineer who could be exploited. American POW camps operated under a rigorous classification system. Basic security screening separated ardent Nazis from ordinary soldiers, officers from enlisted men, and, crucially, identified those with specialized technical training. By summer 1945, numerous camp compounds contained clusters of engineers, mechanics, chemists, and other specialists, many of whom deliberately downplayed their expertise during initial questioning. At Fort Campbell, Kentucky, Camp Forest, Tennessee, and other stateside POW facilities, these technical personnel found themselves in a strange limbo. American intelligence officers continued interviewing them, cataloging expertise in aircraft design, chemical processes, ballistics, radio technology, and other fields where German innovation had, in some areas, surpassed Allied capabilities. Hey folks, thanks for watching this deep dive into a little-known aspect of World War II history. If you're enjoying this documentary, please hit that subscribe button so you don't miss our upcoming episodes on forgotten war stories. We'd love to know where you're watching from, so drop that in the comments below. Now back to the fate of these German technical prisoners. The German technicians' fear was not entirely misplaced. In Washington, heated debates occurred about how to leverage captured expertise. Operation Paperclip would eventually bring selected German scientists to America under special arrangements. But for thousands of technically trained POWs, no clear policy existed regarding their knowledge or labor. Military-industrial complexes across America faced production challenges as wartime contracts shifted toward Pacific theater needs and early post-war planning. Captain Robert Thornton, an Army engineer officer assigned to POW labor allocation at Fort Leonard Wood, Missouri, noted in his official reports that The wastage of technical talent among the prisoner population represents a missed opportunity, particularly as production demands continue to strain domestic technical resources. Daily life in these early POW camps reinforced German fears. Standard Geneva Convention rules stipulated that prisoners could be required to work, with certain restrictions on the nature of that work. Enlisted men could be assigned labor duties, and many German POWs already worked in agriculture, food processing, and basic manufacturing. But using prisoners' advanced technical skills presented different ethical and legal questions. The German engineers watched as their comrades departed daily for farm fields and canning factories, receiving the nominal pay required by international law, about 80 cents per day in canteen credits. For general labor, this arrangement was clearly defined. But what about designing electrical systems, consulting on manufacturing processes, sharing advanced technical knowledge developed through years of specialized education? The Geneva Convention offered no specific guidance. "We assumed our technical knowledge would be extracted without compensation," wrote Friedrich Hoffmann, an aeronautical engineer held at Camp Polk, Louisiana. "It seemed Americans would face a choice between respecting our professional dignity and exploiting our expertise. Many of us expected the worst." This anxiety wasn't helped by initial American approaches. Intelligence officers questioned technical prisoners extensively about German equipment and processes, often in interrogations that felt coercive rather than collaborative. Technical manuals, diagrams, and documentation were confiscated for translation and analysis. From the German perspective, these actions seemed to confirm their value as intellectual resources rather than as men entitled to basic dignity. As 1945 progressed, the situation reached a crossroads. American military and industrial leaders increasingly recognized the potential value of German technical knowledge, particularly in fields like rocketry, jet propulsion, synthetic materials, and precision optics. Yet without a structured program that respected both international law and professional standards, this knowledge would likely remain locked behind the reticence of prisoners who feared exploitation. In August 1945, with Japan's surrender bringing the global conflict to a close, a pivotal decision would transform these engineers' captivity and ultimately contribute to America's post-war technical advantage. But first, military authorities would need to convince these skilled prisoners that in America, even enemy expertise had value worth paying for. By late 1944, as the American military processed thousands of German prisoners, a curious discovery began to emerge. Among the men in standard-issue POW garb were some of Germany's finest technical minds. Engineers who had designed advanced fighter aircraft, diesel mechanics who had maintained the Wehrmacht's tank divisions, and industrial specialists who had kept German factories running despite relentless Allied bombing. Colonel Robert Sharp, assigned to POW operations at Fort Hunt, Virginia, recalled the moment this potential became clear. "We were interviewing a prisoner about routine matters when he casually mentioned his work on fuel injection systems. Within an hour, we realized we had captured one of the developers of the BMW 801 radial engine." This pattern repeated across POW camps in America. At Camp Shelby in Mississippi, intelligence officers found metallurgists. In Fort Bliss, Texas, they discovered optical engineers who had worked on advanced gun sights. At Camp Atterbury in Indiana, they identified chemical engineers with expertise in synthetic rubber production, a material still in short supply in America. The U.S. military faced a dilemma. America's industrial capacity had proven decisive in the war effort. But German technical expertise in certain specialized fields remained superior. The question became how to leverage this unexpected resource. particularly as tensions with the Soviet Union began to simmer and a new technological race loomed on the horizon. Major General Philip Hayes, overseeing POW operations for the War Department, summarized the situation in a March 1945 memorandum. "We have within our camps technical knowledge that could benefit American industry and military development. The question is not if we should utilize these skills, but how we might do so while maintaining our obligations under international law." The Geneva Convention of 1929 established clear guidelines for POW labor. Article 31 permitted the employment of prisoners in various capacities, but prohibited work directly connected to war operations. Article 34 required that POWs receive wages for their labor. While the convention allowed for basic agricultural and infrastructure work, it had never contemplated the unique situation of highly specialized technical labor. Captain Howard Miller, a former industrial relations specialist assigned to the Provost Marshal General's office, recognized the fundamental issue. These men aren't ordinary laborers. They're professionals with advanced degrees and years of specialized experience. Asking them to work without appropriate compensation would not only violate the spirit of the Geneva Convention, but would eliminate any incentive for quality work. In spring 1945, as victory in Europe became inevitable, the War Department authorized a classified program that would later be known as the Technical Specialist Incentive Plan. Under this program, German POWs with verified technical expertise could volunteer for specialized work projects. Unlike regular POW labor, which paid 80 cents per day in canteen credits, technical specialists would receive compensation commensurate with their skills, though still below equivalent American wages. The payment structure was carefully designed. Engineers with doctoral degrees could earn up to $4 daily, transferred to special accounts. Master technicians received $3, while technical assistants earned $2. While modest by American standards, these wages represented significant compensation by POW standards, especially when accumulated over months. When first approached, many German engineers responded with disbelief. Hauptmann Werner Schulz, a captured aeronautical engineer held at Fort Devens, Massachusetts, later wrote in his memoir, "We assumed this was some form of psychological warfare. The Americans would promise payment, extract our knowledge, and then claim we had aided their war effort. We had heard too many stories about Russian treatment of German specialists to believe otherwise. The American approach required building trust through transparent demonstration." Lieutenant Colonel James Reynolds, who oversaw the program's implementation at 3 Eastern POW camps, described the methodology. "We started small. We asked for technical assessments of equipment they were already familiar with, paid them as promised, and established a record of trust before moving to more substantial projects." By summer 1945, with the European conflict concluded, participation increased dramatically. At Camp Huntsville in Texas, a compound housing numerous technical specialists, volunteering rates rose from 15% in May to over 60% by August. Similar patterns emerged across the POW system. The program's economic structure revealed American pragmatism. Rather than offering immediate cash, compensation accumulated in accounts that prisoners could access only for approved purchases within camp canteens. The remainder would be paid upon repatriation, creating both an incentive for quality work and a reason to maintain cooperative behavior until release. A War Department economic analysis completed in September 1945 determined that the program, despite its costs, delivered exceptional value. A report noted, "For the $2 million in specialist compensation budgeted, we estimate receiving technical knowledge that would cost approximately $25 million to develop independently through domestic research programs." The technical projects themselves remained classified, but declassified records indicate they encompassed diverse fields: optical coating techniques, precision manufacturing methods, synthetic material production, and specialized metallurgical processes. Of particular interest were German advances in miniaturization, an area where American industry had lagged. For the German engineers, the program offered more than financial compensation. Dr. Heinrich Weber, a chemical engineer specializing in synthetic petroleum production, expressed the sentiment in a letter to his family. For the first time since capture, I am treated as a professional rather than merely a prisoner. They ask my opinion and consider my expertise. This dignity is perhaps worth more than the modest payment they provide. American military administrators observed another unexpected benefit. Captain Richard Townsend, security officer at Camp Clinton in Mississippi, reported, "The specialist program has improved camp morale broadly. Even prisoners not directly involved see that cooperation brings better treatment. Disciplinary incidents have decreased 40% since implementation." By late 1945, with atomic weaponry demonstrating the dawn of a new technological era, the program expanded further. The Joint Intelligence Objectives Agency formalized procedures for identifying and utilizing German technical knowledge across both civilian and military applications. The groundwork was being laid for what would eventually become Operation Paperclip, the more famous program that would bring select German scientists to work directly in the United States. As winter approached, the specialists' compensation program faced its greatest test. With victory secured and demobilization accelerating, budget-conscious voices in Washington questioned continued funding. The debate reached President Truman's desk in December 1945 when the first German-designed technical drawings began appearing on American engineering tables by late 1944. What started as tentative cooperation soon became a remarkably productive partnership. At Camp Forest in Tennessee, a group of captured Luftwaffe engineering officers initially refused to assist with aircraft maintenance problems. Their resistance melted when shown the payment vouchers they would receive, 80 cents per day for skilled work, significantly above the 10-cent standard POW labor rate. "I thought they were tricking us," recalled one former German engineer in a 1978 interview with the Smithsonian. "In Russia, they worked our colleagues to death in the mines. Here, the Americans were offering payment slips that could be redeemed for canteen goods, and even promised a portion would be held in trust until our release." The payment system proved crucial. While modest compared to American civilian wages, it represented both practical value and dignity recognition. Technical specialists earned between 80 cents and $1, 25 daily based on skill level and project importance, with records showing some specialists accumulated hundreds of dollars by war's end. At Fort Bliss, Texas, former Wehrmacht communication specialists repaired radio equipment while teaching American technicians the inner workings of advanced German field communication systems. The repairs saved thousands of dollars in equipment costs, while the knowledge transfer proved invaluable. What surprised many Americans was the prisoners' initiative. Some began suggesting improvements to American designs. The program expanded rapidly as skepticism faded. By mid-1945, over 200 German technical specialists were participating across specialized camps. At Camp Papago Park in Arizona, irrigation engineers helped design water management systems for arid agricultural regions. In Michigan, automotive specialists consulted on vehicle durability improvements. Metalworking specialists taught precision casting techniques at facilities throughout Pennsylvania and Ohio. One notable success occurred at Fort Meade, Maryland, where German optical engineers helped resolve manufacturing defects in precision lenses for military applications. Their work reduced rejection rates by 47%, saving over $320 in production costs, according to War Department accounting records. The German specialists received recognition and enhanced compensation, including supplementary rations and improved quarters. The effect on guard-prisoner relations was transformative. Technical POWs no longer faced the boredom and frustration typical of regular camps. Guards began treating them more as colleagues than captives. Army reports noted declining discipline problems in specialized camps, with one commander writing, "These men are invested in their projects and their future earnings. They police themselves and maintain professional standards without supervision." The technical documentation effort became particularly valuable. U.S. intelligence officers realized that capturing knowledge was as important as capturing equipment. German engineers were provided drafting materials to recreate designs from memory, explain manufacturing processes, and document engineering decisions. This massive knowledge transfer filled thousands of technical volumes, covering everything from synthetic rubber production to advanced metallurgy techniques. German specialists' work extended beyond direct military applications. At Camp Gordon Johnston in Florida, POW civil engineers helped design flood control systems. In Oregon, forestry experts introduced European sustainable harvesting techniques. The work had immediate practical value while establishing professional connections that would outlast the war. Not all projects succeeded. At Fort Hunt, Virginia, efforts to have German rocket specialists recreate aspects of V-2 technology produced limited results until the actual designers were brought from Europe under Operation Paperclip. Similarly, attempts to extract advanced radar knowledge sometimes faltered when the specific specialists needed weren't available among the captured population. As the war ended, the program created unexpected opportunities. When repatriation began in 1945-46, many German engineers requested permission to remain in the United States. While most were still returned to Germany due to immigration restrictions, approximately 700 specialists were permitted to continue their work under civilian contracts. Their technical skill and now fluent English made them valuable employees as Cold War industrial competition intensified. These German engineers formed tight-knit communities in places like Huntsville, Alabama, and White Sands, New Mexico. Their families often joined them by 1948, creating cultural bridges between former enemies. Many eventually became naturalized citizens, contributing to America's technological leadership during the 1950s and beyond. The program's legacy extended beyond technology. It demonstrated how professional respect could overcome wartime animosities. German engineers who returned home often maintained correspondence with American colleagues. Some facilitated business relationships during Germany's reconstruction, while others eventually returned to America as immigrants. The experience proved transformative for American military policy as well. The successful technical cooperation influenced how specialized POWs would be handled in future conflicts. The principles established, fair compensation, professional respect, and voluntary participation, became standard doctrine for intelligence exploitation of technical prisoners. Perhaps most significantly, the program revealed that treating enemy specialists with dignity yielded better results than coercion. As one Army assessment concluded in 1947, the voluntary cooperation of German technical personnel, properly compensated and professionally respected, provided greater intelligence value than any amount of forced interrogation could have achieved. The engineers who once feared technical slavery instead found professional respect. They had entered American POW camps expecting exploitation, but discovered something unexpected: recognition of their skills through fair compensation. This pragmatic American approach not only yielded immediate technical benefits, but helped lay groundwork for the scientific cooperation that would define the post-war era.